This one.
Yes, sir.
So tell me, first one, aromatic, not aromatic.
Sir, not aromatic.
Sure. So first, why not aromatic? What is the problem? Cyclic BA, planar BA. What is the problem?
The pi bond.
Pi bond या pi electron?
Yes, sir, pi electron.
Okay. थोड़ा सा यहीं पे थोड़ा कैच हो जाता है. I think कुछ एग्जांपल्स कराए थे कि नहीं कराए थे आप लोगों को? Did you write this example?
Yes, sir.
साइक्लो. ओके. तो यहाँ पे कितने होंगे बताइए जरा. How many pi electrons in this case?
Four.
How many? 4. ठीक है. तो यहाँ पे कितने होंगे आप बताइए. How many here then?
6.
6 ना. So it will be aromatic, not aromatic.
Aromatic.
Aromatic. ठीक है. आप लोग को आया हिबा, खालिद, सलमान.
Yes, sir.
Sir, you're
You got it?
explaining B question, right?
Sorry.
You're explaining B question?
A.
Oh yeah, okay, sir.
A you got as aromatic, Khalid?
Yes, sir. Yes, sir.
Okay. What about B? What about B, guys? Tell me. Hamza, Hiba, Khalid, Salman. Tell me, guys. What about B?
B is non-aromatic.
Why non-aromatic?
Sir, because it has one sp3
है ना.
carbon.
तो ये planar नहीं. It is not planar. No, not planar. What about C? Aromatic or not aromatic?
Aromatic.
Aromatic because it has
B is aromatic.
two different rings, and both the rings, even if one of the rings is aromatic, the compound will be aromatic only. Okay. So this is also aromatic, and this is also, both of these things are aromatic rings. That is why we will say that it is aromatic. Now, when you have two different rings connected via bond, then you look at the rings, separate both the rings. Okay. Now, are C and D similar type of situations, or here also we have two rings, here also we have two rings? So are these same, or what do you think? They are different?
Sir, they are
Kind of
different.
same.
Kind of same. नहीं, different. Hamza. देखिए यहाँ पे क्या है ना, like in this D1 we have one shared bond, correct? Yes or no?
Yes, sir.
But there no bond is shared. If I look at this, this is one ring, this is one ring. So when I'm making these two rings, I am not sharing any bonds. But here we have one bond which is shared. So these type of rings are known as fused. दो था उसको एक कर दिया हमने. So दो को fuse करना, fused ring. Fuse means we had two rings, now we have made one ring. How one ring we have made? How have we made one ring? So this is the one ring. देखिए यहाँ से start कर रहे हैं हम. What if it is cyclic? Then I will not be putting my pen up and completely drawing the structure. So I did not pick my pen up and I drew the complete cycle. So this is the ring. And whenever you have fused ring, you will check aromaticity in the fused ring. Okay, not two separate rings. ये एक ring में बस आप check कीजिएगा. No, we have, this is cyclic obviously because it is a ring. Planar. So all the carbon atoms, you can see it has a pi bond. Yes or no? All the carbon atoms. No matter
Yes,
which
sir.
carbon atom you choose, so it has a pi bond. That means all of them are sp2s. That is why it is also planar. Now, how many pi electrons? How many pi electrons? How many pi bonds? 5 pi bonds, no? So 10 electrons. Now you will put this in the equation 4n plus 2. 4n plus 2, it is equal to 10 electrons. So n will be equal to, 4n will be equal to 8 electrons, and n will be equal to 8 upon 4, which is equal to 2. So that is why this is going to be what? This is going to be aromatic, right? N is a whole number. This is aromatic. Any problem, guys?
No, sir.
No. Okay. So let us continue our electrophilic aromatic substitution reactions. I hope you have done till nitration in your notebook. Today we will do halogenation. Today we will be doing halogenation and others also. 17 Feb, Thursday. Halogenation. So in halogenation, we have benzene ring, and we react this with any X2 in the presence of AlCl3, presence of anhydrous AlCl3, and what happens? We get a X atom attached on the benzene ring. So in this case, the electrophile is X positive, है ना? So this is how you are going to identify the electrophile. So when you had NO2 attached, what was the electrophile? NO2 positive. When we are attaching X, what will be the electrophile? X positive. Can you remember this? How to identify the electrophile? Yes or no? Please tell me. Yes or no?
Yes, sir.
Okay. Again, we are now looking at the mechanism. We are looking at the mechanism. How many steps are there in electrophilic aromatic substitution mechanism? Tell me. How many steps?
Three
Three
steps.
steps. Na? First step is what? What is the first step? What is the first step, guys?
Generation of electrophile.
Very good. Generation of electrophile. Now, for our mechanism, I am going to take X, that is the halogen, as chlorine. So we have chlorine, which is bonded to chlorine. Chlorine bonded to chlorine, Cl2. Plus we have AlCl3. Now we know that AlCl3 is what? It is a Lewis acid. Kaise? Its octet is not complete. It has a vacant orbital. Aluminium. It has 3 bonds with chlorine. Now, if it has 3 bonds with chlorine, that means how many electrons? 6 electrons in the outermost shell of aluminium. So it is less than 8. That means octet is not complete. Aluminium will accept a pair of electrons. So it accepts a pair of electrons like this. And since the bond is broken, one of the chlorine attaches to aluminium. And we get AlCl4 negative, because aluminium was negative. Now it is attached with chlorine, which is coming with 2 electrons. So it gets a negative charge. Plus we get a Cl positive. Plus we get another atom, that is the electrophile Cl positive. Is this clear? Yes or no? Please tell me. Generation of electrophile is clear? Yes or no? What happened, guys?
Yes, sir.
Okay. Next step. What is the next step? Formation of carbocation. Formation of carbocation. Now, in formation of carbocation, a benzene ring will attack on the electrophile, breaking a pi bond and forming a carbocation, that is especially known as the rhenium ion. We have hydrogen, and let us focus on this bond, hydrogen. This bond will attack on chlorine. One of the carbon atoms will get the chlorine, the other carbon atom will get the positive charge. We have our benzene ring with this bond broken, but these bonds are intact as it is. And here, let us say we have hydrogen, and here we have added chlorine, and hydrogen also is present. Nothing has gone. We have just broken a pi bond. That is why this will get a positive charge. Is this clear? Yes or no? Please tell me. Is this clear? Yes or no?
Yes, sir.
Formation of
Yes, sir.
carbocation. This carbocation, what is the name of this carbocation? What is the name of this carbocation? Arenium ion. This is known as arenium ion. Okay. Now, third step is you can write the resonating structure if you have been asked to write the mechanism ना. So nitration से देखिए वही similar resonating structure होंगे. वहाँ पे बस nitro group है. यहाँ पे you will have Cl. Next step that we have is loss of proton. Loss of proton. So here we have hydrogen. Oops. यहाँ पे एक गलती हो गई. ये pi bond तो नहीं होगा. And here we have chlorine. Here we have hydrogen. Here we have a positive charge. Here we have a positive charge. And we are going to react this with AlCl4. AlCl4 negative. Now, one of these chlorine atoms, it will attack on this hydrogen. It will attack on this hydrogen. So it will abstract the H plus ion. So if it is abstracting the H plus ion, that means hydrogen is leaving the electrons. So hydrogen will leave the electron and it will form a pi bond like this. And you will be getting chlorine atom here. Okay, a chlorine atom attached here. So this is chlorobenzene. बताइए, any doubt till here? And what are the products? So one of the chlorine attacked on hydrogen, so you will form HCl plus AlCl3 will also be formed. बताइए, कोई दिक्कत? Any problem till here?
No, sir.
No, no. Okay, very good. Next is Friedel-Crafts alkylation. एक बार प्लीज इस रिएक्शन को देखिए. Look at the electrophile, look at the group. Giving you a few seconds because I'm going to ask what is the electrophile. Okay. In Friedel-Crafts alkylation, what is happening? We have benzene ring. React this with alkyl halide Rx in the presence of anhydrous, any Lewis acid. Okay, any Lewis acid. Let me write it like this: Lewis acid. तो क्या क्या हो सकता है? AlCl3, FeBr3, FeCl3. So all of these things you can use instead of AlCl3. Previous reaction maybe. Okay, in the previous reaction also. And an alkyl group is attached on the benzene ring. Whatever haloalkane we have used, that alkyl part is attached on this benzene ring. So tell me, what is the electrophile? What is the electrophile, guys?
X plus R plus, sorry.
R plus. Hamza, Hiba, Salman, आप लोग का आया R plus है ना? Electrophile, yes or no?
Yes, sir.
Just identification. Okay, just identification. Now, again in mechanism, the first step will be what? Mechanism में what will be the first step? बताइए.
Generation electrophile.
हाँ, जब तक बोलिएगा नहीं याद नहीं होगा, ठीक है ना? I am asking only because you have to remember these three steps. Generation of electrophile. Generation of electrophile. Now, in generation of electrophile, we will take the example of CH3Cl. We will take the example of CH3Cl plus AlCl3. So again, this chlorine atom, the bond will break like this. Aluminium को आपको chlorine मिल जाएगा, and it will be AlCl4 negative plus CH3 positive. So when we have got the electrophile, the next step is going to be formation of carbocation. Formation of carbocation. Now this step is going to be very similar to the previous reaction that we have done, in which the benzene ring, through one of its pi bond, attacks on the electrophile with breaking the pi bond and forming a carbocation. Third step will be again loss of hydrogen. So in this we have the benzene ring. One of the chlorine atom will attack on this hydrogen. Here we have hydrogen. This hydrogen will leave the electrons to this bond. So the pi bond will be reformed. So you have got the benzene ring again with a CH3 alkyl group attached, and again you are getting HCl plus AlCl3. Please tell me, is this fine till here? Yes or no?
Yes,
Okay,
sir.
all of you. Okay, fine. So next is, now important point is, wherever you have the chlorine atom, wherever the halogen is attached on the carbon atom, from there you are going to form the bond. Okay, so I'm going to give you some questions. Write the products for following. And identify the reaction, whether it is halogenation, nitration, alkylation, what is it? And identify.
Sir, do we have to write all the products or just the main one?
That's the main one, just the organic one. Main product. Write this down. When you are done writing the answers, click a photo and send it to Nishkarsh sir. And then raise your hand when you have sent the answer. Khalid has sent. Okay, Khalid. I just got it. I just got it. What about others? Hamza, Hiba.
You're doing it.
हाँ ये देखिए खालिद यहाँ पे आपने ना देखिए सेकंड वाले क्वेश्चन में आप देखिए इफ यू विल ब्रेक द बॉन्ड ना देन कार्बन पे पॉजिटिव चार्ज कहाँ आएगा वेयर विल यू गेट द पॉजिटिव चार्ज इन विच कार्बन CH3 या CH2
CH2.
तो फिर बेंजीन जब अटैक करेगा तो कहाँ पे अटैक करेगा
Okay, I got my
got
mistake.
it okay other things are fine good Still waiting for you guys. क्या हो गया? हमजा, हिबा, आप लोग का नहीं आया आंसर? किसी में दिक्कत आ रही है आपको? हमजा, हिबा एंड सलमान, प्लीज टेल मी.
Sir, a little in the second one.
सेकेंड वन. तो देखिए इसमें ना थोड़ा सा प्रोसेस को देखिए. व्हाट विल हैपन? दिस बॉन्ड विल ब्रेक ऐसे, है ना? You'll have the benzene ring. This will be their electrophile, correct? Yes or no?
Yes, sir.
अब बताइए बेंजीन जो अटैक करेगा कहाँ अटैक करेगा? कार्बन नंबर ए पे अटैक करेगा या कार्बन नंबर बी पे अटैक करेगा? Which is more electrophilic? Which has less electron? A या B? जी बोलिए.
The B.
है ना, बी पे अटैक करेगा. आ तो गया आपको? जो बी पे अटैक करेगा, बेंजीन का किसके साथ बॉन्ड बनेगा? ए के साथ या बी के साथ?
Sir,
किसके साथ
B.
बॉन्ड बनेगा? बी के साथ. तो जब भी whenever you are going to make a product, you make the product like this carbon. बी के पास कितने हाइड्रोजन है?
Sir, 2.
उसको लिखिए. फिर बी ए के साथ बॉन्डेड है तो ए को लिख दीजिए. दिस इज योर प्रोडक्ट. ओके.
Yes, sir, understood.
बाकी ये तो कर लिया होगा आप लोगों ने, है ना?
Yes, sir.
बी आर अटैच हो जाएगा एंड हियर यू विल बी अटैचिंग NO2 ग्रुप. दिस इज halogenation. This is Friedel-Crafts alkylation. This is nitration. ठीक है? Any problem till here?
No, sir.
No. I can scroll down now.
Yes, sir.
So NCERT in like inside the text, this is not a question in NCERT as exercise, but inside their text आप ऐसे देखिएगा NCERT ना कुछ सवाल कर देता है. So there they have asked, why do we get isopropyl benzene? What are we getting? This is my product. Why do we get? This is my product isopropyl benzene. Isopropyl याद है? At least नाम याद होना चाहिए आप लोगों को. ऐसा नहीं है ना कि पहली बार सुन रहे हैं isopropyl. You
No,
have
sir.
heard it ना?
Yes,
you have
sir.
heard it. ठीक है, मे बी याद नहीं हो या याद हो अलग बात है, लेकिन सुना है काफी इतना. On treating benzene with 1-chloropropane instead of N-propyl benzene. So what they are saying that I am treating benzene with 1-chloropropane. This is 1-chloropropane in the presence of anhydrates AlCl3. ठीक है ना? So सबसे पहले तो ये होगा कि you will have a electrophile that is CH3 CH2 positive plus we had our benzene ring. तो हमको क्या मिलना चाहिए था? I should have got benzene ring attacked on the CH2 plus carbon is bonded to CH2, which is bonded to CH3. So I should have got N-propyl, that is normal propyl. This is propyl here. Normal propyl benzene, N-propyl benzene. But we are not getting this product. This was expected. So in the actual reaction, when we react this benzene ring with CH3, CH2, CH2, Cl, magically I'm getting isopropyl benzene. Isopropyl means, and this is the point of attachment, propyl group with the point of attachment of second carbon. So we have, this is the product we are getting. अगर हम खोल के लिखें, so it is CH, CH3, CH3. Okay. So now we have to understand why is this happening? Why is this happening? So the reason of this is something to do with the carbocation, because carbocation तो वही बनेगा. There is no question about what will be the carbocation form. The carbocation will be the same carbocation that we have formed in the first reaction. Okay, this is the actual, and they are asking the reason. This is the actual reaction that happens. They are asking the reason why it's happening. Now, let us look at the generation of electrophile here. So CH3, CH2, CH2Cl plus AlCl3 is going to give me CH3, CH2, CH2 positive plus AlCl4 negative. Now this carbocation is very important. In this carbocation we have CH3, which is bonded to carbon, which has hydrogen atom here and here, singly bonded to carbon atom, which is having a positive charge. Yes or no? It is having a positive charge. Now I want my focus on these two carbon atoms, So when I focus on these two carbon atoms, I see that this carbon atom has some sp hybridized orbital bonded with another carbon atom, and this carbon atom has empty p orbital. Yes or no? Yes or no, guys? Tell me.
Yes, sir.
Here we have a CH bond. Here we have a CH bond. Here we have a CH bond. Now what happens? So this has, I am marking it with blue. This is what? Electron deficient. Here we don't have any electron. And here we have a bond. This bond has electrons. Right? This bond has electrons. So we know that one thing is you can understand this through hyperconjugation also. You can also understand it through shifting of bond like this from high density to low density. So the hydrogen shifts and it forms okay, with a positive charge. Now this is a hydride shift, or you can understand it through hyperconjugation also. So in hyperconjugation, you know that what happens here, we shift the bond like this and we make the hyperconjugating structure CH3 carbon. Here we have a, now here we have a double bond. Right, and here we have the H positive, Now the H positive, now it can attack on these two carbon atoms. यहाँ पे भी attack कर सकता है, यहाँ पे भी attack कर सकता है, right? So we are going to get two products, CH3, CH2, CH2 positive, or I can get CH3, CH positive and CH3. Now in these, when we have hydrogen positive, after the hyperconjugation, when the hydrogen is now again going to make a bond with carbon atom, it has two carbon atoms on which it can make bond. So what it will prefer? It will prefer first carbon or second carbon. So when it prefers the first carbon atom, I get a 1 degree carbocation. And if it attacks on the second carbon atom, I get a 2 degree carbocation. Here I have how many alpha hydrogen? 2. Here I have how many alpha hydrogen? 6. So obviously this is more stable. So after the hyperconjugation, after one hyperconjugation, we mostly get this product, that is the 2 degree. This is the 2 degree carbocation. Is this understood? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
So the main thing is that you have to understand what happens. We have what we know as a hydride shift. We have CH3, CH2, CH2 positive. It undergoes a 1,2 hydride shift. That means from first carbon to second carbon hydride shift, H shift, and it forms CH3, CH positive, and CH3. Now we have what? Now this is more stable. That is why this carbocation is going to attack on the benzene ring, and we are going to get from this isopropyl benzene. So when it attacks on the benzene ring, CH3. Sorry, not it will not attack on benzene ring. Benzene ring will attack on this electrophile, because we show from electron rich to electron poor like this. So after a few steps, after the loss of proton and all, you can directly write we are going to form. So the benzene ring is attacking on the carbon with positive charge. So I will make that carbon first. Then I will look at that this carbon has a hydrogen. So I will attach hydrogen. It also has a CH3 group. Then I will attach a CH3 group. I will also attach a CH3 group. Now please tell me, is this clear, yes or no? Is this
Yes, sir.
clear, guys?
Yes, sir.
Here we can write since 2-degree carbocation, since 2-degree carbocation is more stable, CH3, CH2, CH2 positive undergoes hydride shift to form CH3, CH positive, CH3, which is 2-degree carbocation more stable, 2-degree carbocation and more stable. It attacks, or rather I should say the benzene attack on. Then when benzene attacks, we get isopropyl benzene. Is this clear? Is this clear, guys? Okay. Next is Friedel-Crafts acylation. In this we react this benzene with CH3COCl, or rather I can say RCOCl, R C double bond O Cl. Again, the presence of any Lewis acid, that is, let us say for this case anhydrous AlCl3, and we get C double bond O and R. So since C is bonded to the benzene ring, the electrophile in this case will be R C double bond O positive. This will be our electrophile. This will be our electrophile. If I look at the mechanism here, the first step will be generation of electrophile. I hope you can see this happening. Again, R, we have R, C double bond O, Cl, and AlCl3. So this bond attacks on the aluminium, which is Lewis acid, and it forms R, C double bond O, the positive charge. This is our electrophile. Then you can write the second step and the third step. Yes or no? Yes or no, guys? You can write it now.
Yes, sir.
Okay. Now, in acylation, there is also one more important reaction, that is, we can use acid anhydride also in place of acyl chloride. This is okay. What is this? This is acyl halide. This is acyl halide. Benzene with acyl halide in the presence of AlCl3. We can also use acid anhydride. So when I use acid anhydride, I will have benzene ring to be the same thing plus R C double bond O oxygen C double bond O and then some other R group. Again, this will be also in the presence of AlCl3. So here what happens? Here you can see that RCO Cl. This is going to attack on the benzene ring, and the rest of this, it is going to form carboxylic acid. Okay, it is going to form carboxylic acid. So we will get benzene ring with carbon double bond oxygen, the R group plus R C double bond O OH. Okay, this is acid anhydride. Acid anhydride. Is this clear? Yes or no? Tell me. So this is
Yes, sir.
just remember this as a side thing. Okay. Generally, in school they don't give this reaction, but it is present in NCERT. So just before going to the examination, there are a few things that you have to look. This is one of those things that acid anhydride also is going to give me. This is what benzophenone. Now, this is anything which is having a ketonic group, CU group. Okay. So next is sulfonation. Sulfonation. In sulfonation, we use benzene ring when it is treated with H2SO4. It is treated with H2SO4. We get benzene sulfonic acid, that is benzene ring with SO3 H group attached. Now, in this, the generation of electrophile, there are two mechanisms. Both of them are fine generation of electrophile. Actually, let me just write the mechanism only. So I will first of all write a mechanism that is more often nowadays it gets more preference, that H2SO4, it has an ability that it can decompose into SO3 plus H2O. Okay, and also this use some heat. So SO3 and H2O. So whenever you have H2SO4, you will have some sulfur trioxide present. Sulfur trioxide will be present, and sulfur is a third period element which has a vacant d orbital, so it can also act as a electrophile. So what happens? Then the benzene ring, it attacks on the sulfur trioxide. And hence it is going to form. So as soon as it attacks on sulfur breaks a bond like this, and we get something like this. And this is after the protonation, loss of proton and all. I get double bond O, single bond O negative, and double bond O. Now there are H2SO4 present here, so for from H2SO4 I will get H plus ions, and this will attack on this H plus ion, and I will be forming benzene sulfonic acid like this. So in this case, I can say the electrophile is what? Electrophile is SO3 only, because this is the electrophile that is getting attacked by benzene. The another one is that I have to revise you this reaction, H2O plus H2O. I hope you have remembered some of equilibrium. It is going to give me H3O positive plus OH negative. So similarly, a similar type of reaction happens with H2SO4 and H2SO4. We have sulfur, double bond O, OH, and OH. Plus I have sulfur double bond O, and OH. So this is the structure of H2SO4. So one of the H2SO4, it acts as base. It attacks on the hydrogen atom, and it forms. So from here I will be getting HO double bond. Sorry, this will be single bond, not double bond. Okay, HO and sulfur, double bond O, double bond O, single bond O negative. So this is HSO4 negative that I'm getting. Plus here I will be getting H bonded to oxygen, sulfur double bond O, sulfur double bond O, OH. Now this oxygen attacked on the hydrogen atom, that is why like this. You will be getting H2 hydrogen atom attached to oxygen. Then this will be given out as water. Plus I will be getting here HSO3 negative. Now this HSO3 negative, sorry, HSO3 positive, because the bond has been broken and this bond electron it is given to oxygen, that is a positive charge here. HSO3 positive I will be getting. Now this HSO3 positive can also act as a electrophile and can be attacked by benzene ring. Can be attacked by benzene ring for the formation of benzene sulfonic acid. This is benzene sulfonic acid. Okay, so there are two different mechanisms, both are fine, but nowadays this is given more preference, the first one that I did. So for electrophile you will give SO3. Okay, you will be giving SO3 as the electrophile in benzene sulfonic, in the sulfonation of benzene ring, Okay, so this is it for today, and I have to share this PDF with you guys now. So let me